Hi everyone, thanks Robbie. So my name is Manuel Serrano, I'm a researcher at INRIA in France. And my talk today will be about Hopjs. The whole purpose of this presentation is to give you an overview of the language, just to get you an intuition of what it looks like programming with this system. So Hop is meant for programming web application. And by web application, I really mean standard web application. In this model, we consider that we have a server that is running somewhere, and the true application starts when a client asks something to this server. And for me, asking something is when you use your mobile phone flashing a QR code, the application starts. If you are a little bit old-fashioned, maybe it means that you will type in some character in the URL bar of your navigator, and that's when the application really starts. For us, an application is something that you receive on your client, an HTML tree materialized here by this blue triangle, which contains HTML for describing the GUI, and inside this HTML document, you have JavaScript programs that get executing. And so you have a parallel execution in between the servers that is going on and this JavaScript code that runs. A novelty that has been introduced by the Web 2.0 is that new interaction may occur during the execution because a JavaScript expression decides by their own decision to make new requests in direction of this server. And in response, you get back a new HTML fragment. And what you have to do in standard web application is to make a collection of the two, to merge the two, and to establish a link between what you already had and what the new things you receive. And all the problem is dynamic linking, dynamic loading, dynamic overloading, hot swapping, all these kind of things. And this is a programming model you really have on the web. And this is a programming model we do support in Hopjs. So Hopjs is meant for programming this kind of things. And we even go one step further, because in Hop, we do not consider only one client and one server, but we also consider one client and a bunch of servers, and all these servers communicate one with each other. And so what Hopjs offers is what we call a multi-tier programming. And the idea is that we have one single programming language that automatically splits in between what gets executed on the client and what gets executed on the server. And we manage server-to-server communication, client-to-server communication. That's exactly the purpose of Hopjs. So yes, Hopjs is based on JavaScript. Full-fledged JavaScript, ECMAScript 6, ECMAScript 5 JavaScript, plus a lot of features coming from ECMAScript 6. And on top of JavaScript, we just add 4 constructs that let us do all this multi-tier programming. The first one is inside our JavaScript program, we support XML natively, HTML more precisely natively. So you can use HTML syntax in the middle of a JavaScript program, and inside an HTML expression, we use this $curly bracket sign to mean that we are injecting something inside HTML. And this $curly bracket is now standardized in ECMAScript 6 because this is the syntax we use for template strings. And so this is a regular way of doing this kind of thing in JavaScript these days. Then the second extension we have is a definition of a service. And for us, a service is exactly a plain JavaScript function associated to a URL. That is a JavaScript function that you may call by just using a standard URL. The third extension is this red tilde sign, which is a constructor for constructing a new kind of value, which is client-side program. And for us, in Hopjs, a client-side program is a value computed by the server-side execution. So Hopjs is multi-staged programming, and you keep generating programs that someone else will execute. And when you are in the context of such a tilde thing, you can use the same escape sequence here for injecting value that the generator is owning and that it is using for generating the program that gets executed. So on this presentation, I will make just through specific focus on 3 different aspects of the language. And let me start with this multi-tier generation of HTML. So if you are playing on the web, clearly you will have to generate HTML pages. So let's have a look on how generating such a thing. You can type it in by hand with Emacs. Or if you are a PHP programmer, maybe you can use something like that. You will embed PHP inside HTML. And in this program, actually what you do is that you are implementing a compiler by hand. You are just writing a PHP program that generates HTML. So you are just writing an HTML compiler. And maybe you don't like very much this solution because you are just on your own for generating HTML. So if there is a typo here somewhere, maybe it will be difficult to understand it and to find it and to correct it. If you are a Node.js programmer, Node.js is the solution for JavaScript server-side scripting these days. You will use something pretty similar, except that you will replace PHP with JavaScript, but still you will embed HTML inside JavaScript, and you will be, once again, on your own for generating correct, if possible, HTML fragments. If you use a most modern framework, such as React.js by Facebook, then you have a significant improvement, because in React.js, you have built-in HTML support inside JavaScript. So you can use the HTML syntax, which is much better, and you can insert expression inside this HTML syntax with just a single curly bracket, and your life is easier now. You just have to pay attention that this program is to be executed only on the client side. So this is not multi-tier solution, it's only client-side solution. In Hopjs, we have something almost similar with minor syntactic differences with use of this $. And it looks like as React.js, we have support for HTML. But actually, the two programs are really different, because here we are really talking about a program executing on the server side that will generate something that will get executed later on. So here, this program is really a multi-tier program. And the main difference is that actually what we do have in Hopjs is we have a multi-tier DOM, which means that we have a client-side DOM as usual, and we have a server-side DOM. That is, you can create your HTML documents and manipulate them. And this has nice properties. And for instance, just to show you the kind of thing you can do with this server-side DOM, is you can consider any web page as a regular Hopjs program. So although Hopjs is pretty new, Hopjs is probably the language with the largest set base of source code existing everywhere. And so you can just require any web page and execute it. That's what we do here. We execute the program called lambda the ultimate. We import it with our require form, which is just a standard form for importing a module. We execute it, we obtain an object, and on that object, we can just do querying, filtering, whatever you want. Here, we just extract the element that belongs to the title class, and then on this element, we just, for each of them, we extract the first child element here, then we grab the content, and we display the result on the console. And if I run this program on my Linux terminal, I will get something like this, which is just the title of lambda the ultimate of the day. And you see, just writing this is 3 lines of Hopjs code. And this just illustrates one of the objectives of Hopjs, that is to let you reuse existing resources on the web. So here I'm just reusing HTML pages as regular data on which I will make some computation. I will show you extra example afterward. Now with Hopjs, the things start to be really interesting when you have some interaction with the user. That is when you add user action to your HTML document. And here I have added this piece of code. That is when a user clicks on a table data, it will just execute something on the navigator. So how do you implement such thing with React.js? Well, you do it this way. You slightly modify the program, and actually there are 2 modifications. The first one is that you have to rename the attribute using an uppercase C here, which is a minor difference. And the second difference is that you have to introduce explicitly this function E thing. And this is natural because actually you are just associating a callback to an action, and this callback will take an argument E, and when you just program in HTML, this E is implicit, which is kind of annoying, so it makes sense to have this this explicit here. But this is problematic because now you have a discrepancy in between what you write for the server and what you write for the client. You have 2 different syntaxes, and the 2 programs are not compatible anymore. So for us, we consider this as a problem. And we solve this problem differently with Hop, is that we just use a syntactic mark that says that, okay, we are executing somewhere this program, probably on the server, and in this program, we will generate an expression that someone else will execute. And this, at some point, will mean that we will have to introduce this function E automatically, but syntactically speaking, it's the same program that you will run on the server or on the client. So let's study how these things get compiled and executed in Hopjs. So you start with a program like that, you load it on the server, and the first thing is that you have to compile it before executing it. And the first stage of the compilation is just to get rid of this HTML syntax. So first, we translate this program into these things. So you see that HTML tags are replaced by a function call with just an uppercase transformation. All the attributes, ID equal fib tbl, are just packed into a JavaScript object. And we just embed function call one in each other. And you see also that this tilde sign here is compiled into a call to a constructor, where we just construct an object, and this will be really a server-side object that you will be able to manipulate. Once you have done this translation, we can compile JavaScript to native code, we can run it, and this creates a DOM server-side DOM, which is this data structure representing the table. And at the very end of the execution, if one client asks this value to be loaded inside the navigator, then at the very end, we do compile this into plain HTML. So that's the standard process of executing an Hopjs program. You load it, you run it, and if needed, you compile it to plain HTML and JavaScript. In this simple example, you might have the impression that compiling something inside a tilde expression is just the identity function. But this is a false impression, because there is no restriction on the language you can use inside the tilde expression. And in particular, inside the tilde, you may use JavaScript expression, but you may also use Hopjs expression. So in this example, in my tilde expression, I use a div tag, and this has to be compiled away at some moment by the Hopjs compiler. So when we compile this code, we produce this. And now you see that the compilation of a tilde expression is no longer the identity. It requires a full compilation stage, and a true compilation is going on. And so in Hopjs, we have a compiler that takes Hopjs source code, that generates native code for the server, or that generates JavaScript for the navigator. And you can mix the two compilations, because you can always embed inside one language an expression of the other language. So the compiler has to be parameterized by the target you are willing to generate. So as I have said, there is no restriction in what you can write inside the tilde expression. You can use the HTML syntax. And of course, if you can use the HTML syntax, you can also use tilde inside tilde. So in this program, I now create a div element that also contains a client-side expression that has to be executed at some point. So I will illustrate this with this simple example. This is the only demo I will show during this presentation. It's a full HTML page that just generates one button here with a message click me, and when you click on this function, you will execute this call with this message. The function is defined here. It's a client-side function, and the whole purpose of this function is to create a new button that will be added to your page. The content of this button will be the message it received, and the interesting part is that when you will click on that button, it will recursively call this function that will generate new buttons, etc., etc. So if I run this code, I have my click me button, I click on it, click me too, and each time I click, I add a plus. Pretty simple. You get the thing, but now if I click here, I have just 2 plus, 5 plus, etc., etc. And this is because we have the lexical scoping and lexical nesting of generated generators. That's the idea. Okay, so that was it for generating HTML. Now I will switch to the second part, which is services. So far, applications were just executing on the client. And if you need communication in between a client and a server, then you need a service. And service is the tool that you need for communicating between client and servers, but also from server to server. So the idea is pretty simple. We all know that such a URL is just a kind of external syntax for calling a function called trans with 2 parameters. So the idea in Hopjs is really very simple. This URL is exactly for us equivalent to calling this function this way. So the syntax above is just a syntax for a function call. And we just play with that trick, and that's it. So how do we define a service in Hop? We just create an object of the class hop.service. The first parameter is the name of the URL, and the second parameter is the function you want to execute each time the service is called. And you just provide this in the Hopjs runtime environment, and you're done. You have a server, a web service that is available for everyone. And a service just returns a value. And in that example, I'm implementing a pretty simple, pretty straightforward translator. In the first step, this one is able to translate from English to French the word have. Otherwise, it just declares that it doesn't know how to make the translation. And that's it. This pattern that you see, var, trans, equal, new, blah, blah, is so frequent that we gave it a syntax. And the very same thing can be written this way using this new keyword, but these two programs are absolutely equivalent. How do you use such a thing? And in this example, I use it from a client side. You just call these things. So I have just an input box, something where you type in characters. When you hit the return key, you just call this function. This is just calling this service with the parameters English to French and the text that you find in the input box. This somehow produces the URL that I have already presented, which is embedded inside an object that we call a URL frame. And this object supports several methods, and the most important one is the post method. Post, the meaning of post is just make the call, that is traverse the network, execute the service on the server, get back the result, and when you get the result, invoke this callback on the value you have received. That's the whole thing. Now, as I have said, hop is meant for reusing existing things. So in the following example, I will reuse a realistic translator located as this URL. If I want to use it in hop, instead of declaring it as a hop service, which it is not, I will declare it as a web service using this constructor. And once I have done this, I can use this as a regular JavaScript function that will manage all the things needed for calling this service. So the documentation for this API is described here. It explains me how I should call the service. And so now I can write a wrapper, a JavaScript wrapper to call this service. And I implement this translate text function that just uses service. It receives an argument, it calls the service with that argument. It uses this method, postSync, which is equivalent to post, except that it blocks the execution until the completion of the service. And when the service completes, you have the result in this variable R. And then I do some decoding according to the documentation over there. Now that I have implemented translate text, I'm happy. I can finish my translator, which is as follows. You can consider this as a local cache. If the word you ask to translate is in the cache, I return it instantaneously. Otherwise, I will use this remote service. And now I have implemented a full-fledged natural translator in Hopjs. The problem that I do have here is that posting is a blocking operation. So, and it is needed because in a service you have to return a value, so you have to block until you return the value. And so the problem is that if my memory is overloaded or too long or never responding, I will block my server forever. So this is a problem, and in the rest of the talk I will show you how to get rid of this post thing and replacing it with something asynchronous. And for that, I have to talk a little bit about parallelism and the way we deal with parallelism in Hopjs. So one of the difficulties that we have is that JavaScript is not multi-threaded. So I guess most of you will consider this as a virtue, and maybe it is. But when doing server-side programming, not having several threads might be a problem. But hopefully JavaScript is improving, and now we have web workers and we have promises, and we have integrated that in Hopjs, and this helps us a lot for solving the problem of going from asynchronous to synchronous. So let me talk a little bit about the implementation of Hopjs. When you run the system, you actually start a web server, which runs the on-the-fly compiler, and that has a built-in architecture for implementing web servers. And the architecture we are using is very common. It's just using pipelines. The idea of a pipeline is that when you receive an HTTP request, it will go through different steps before the character being delivered to the client. So in the ACK stage, you just wait for an HTTP connection. In request, you just parse a request. In response, you compute the result that you will ship to the client. And in reply, you just ship the characters. And in Hop, we run plenty of this in parallel in different threads. By default, you have 20, but you could choose to have much more. And the observation that you have to make here is that actually it's only during the response stage that JavaScript is involved. That's the only moment where you invoke a service and you have to compute something in JavaScript. All the other stages are implemented actually in Scheme, and all these are running in multi-threaded different threads and running in parallel. So you may have one pipeline which is parsing the request, while another one is just computing the result in JavaScript, while a third one is delivering the character to the client. And all this run in parallel. And then the other thing that we have is we are using web workers for enabling parallel computation, parallel JavaScript computation. And the idea is that you can associate a web app service with one worker. And when you receive a request, the server automatically makes the routing for selecting the proper workers that has to execute its code for delivering the response. So this way, we have several workers running in parallel. So you may have several JavaScript workers running in parallel. In up, they are implemented using lightweight threads, and the heap isolation is enforced by compilation, not by using server processes. The last thing we have for solving the problem I'm trying to solve is on the pipeline, we have some kind of a new feature here, which is that a service may return a special value that will denote an asynchronous response. And this value will be implemented as JavaScript promises. So when a service returns a direct value, such as a string or a number or an HTML document, you directly ship it to the client. But if a service responds a promise, you keep the connection with the client open, and it's only when the promise is resolved that you will ship the character to the client. As it has been said in the previous talk, JavaScript gives you a lot of freedom, and we do use it in Hopjs. And the way we use it here is by slightly overriding what we can do with a post method. So far, I have used this prototype for a post method. I have said a post is something that accepts one argument, which is a callback. And actually, post is overloaded. You can also call it without an argument. And in that case, post returns a promise that resolves when the call completes. And we simply use that for modifying our program and for getting rid of the post thing. So remember, I have my web service implemented in Hop that uses its local cache. When it's not in the cache, it calls this function, and the problem is the posting over there. How do we get rid of posting? Pretty simple. We just do that, and that's it. We have switched from synchronous to asynchronous. So what is the magic here? Post returns a promise. We create a new promise with a then construct here that is resolved only when the first one resolved. And this is the promise we return here. And so when this is complete, then the characters are delivered to the client. And you see that the nice part, maybe I'm going a little bit too fast, and maybe you have to think about it, especially if you are not very familiar with JavaScript promises. But the important point is that we have been able to switch from asynchronous to synchronous world without any modification of this code. So integrating these promises into the Hopjs pipeline give us some kind of way of bridging the gap in between asynchronous and synchronous world without too much pain. So I think this is it. This is the 3 points I wanted to emphasize today, just to give you an overview of the system. I'm not going into any details. The paper contains some additional detail, but not everything. And of course, maybe the last bit of thing I have to mention is that Hop is available. You can go to hop.inaria.fr. We have an extensive documentation, and you can download the system and play with everything. Thank you very much.
Hi. I've been doing a bit of work with a framework, JavaScript framework called Meteor, that basically has most of the feature that you mentioned. He has templates, so basically it's HTML. He never mixed JavaScript with HTML, and these templates allows only values, basically. These values are reactive values. So there is this asynchronous communication between a client and server. It's based on node, so you can have JavaScript both on side and client. And I'd like to know how you compare Hop.js with Meteor, and if you know about it.
Yeah, Mentor is not multi-staged. You are not able to implement this example I have been presenting with the buttons that generate buttons that generate buttons. This is out of the scope of Mentor, but maybe we can talk of this. And this is a huge difference because this gives us important properties. And if you want additional detail, maybe we can talk offline.
I think you said just enough about the implementation to get us curious, but not enough to be satisfied. So you mentioned that a part of the system is running in Scheme. So do you interoperate with an existing JavaScript implementation, or do you have your own also in Scheme?
So everything is implemented in Scheme, and we are not reusing any things coming from the JavaScript world. So behind the scene, it's all Scheme everywhere. We are using our own JavaScript to Scheme compiler, and then our own Scheme to native code compiler or Scheme to JavaScript compiler.
Dmitry Kosarev from St. Petersburg State University. I have spent some time hacking a common web server called Oxygen/Helium, and it seems the same ideas have been implemented there 5 or 6 years ago. Can you briefly compare these two approaches?
Yeah. So the idea of Oxygen, first I have been implementing Hop, the pure Scheme version of these things 10 years ago. 5 years ago, Oxygen appeared, and now we are redoing the thing in JavaScript. And the whole motivation for redoing the thing in JavaScript was to be able to talk to the JavaScript community, which is much wider than the Scheme community. And then going from Scheme to JavaScript goes with a lot of trouble, a lot of problems you have to solve. And we have a different view of the thing because of JavaScript and because Camel and JavaScript are different. So on the surface, the languages are not the same. And the most important thing is that in Oxygen, you don't have this idea that a client-side program is a value, and you can compute this value. You can inject value, you can modify it, you can do these kind of things. So really having a program being a value that you can pass away is something specific to Hop. Oxygen has a little bit of that, but not at the same level.